Alright, so here's a Master Mason note for you. I know. This one, trouble. She's trouble, boys. You gotta watch out for her.
But a fun week, but a long week.
So I'm now at one of the plenary sessions on fast radio bursts.
This is critical.
I finally left the
Okay,
galaxy,
I want
which
you
is the
guys
human
as Master
current
Masons,
Huxley, who is,
female, I don't care.
a professor
Master
at the
Masons,
Space Institute
to
in
understand,
Canada.
you
She
digging,
used to
you're
work
working
on
the
just
stone
magnetars
right
in our
here.
own galaxy.
Okay, and I'm sorry, hon, I gotta slow you down. I know, it takes some crazy power to slow down a supermassive like this. But what do we have here, guys? Well, I mean, realistically, what are we looking at here? Here's an output of some kind on a computer graph. Alright, that would be the first bit of it. Some radio bursts inside here, radio pulses. So it gives me some stability under 9.8 meters per second, or there's T1 to minus T2. I get that differential, it gives me the value. That time decay gives me, it winds up being this thing being pretty heavy duty. But not really. I'm going to tell you how heavy duty this supermassive black hole really is here. This is just a different one here. A blank one, ready to go. Ready to click it out. And so I want to bring up a concept real quickly about what these lines look like. Interesting. And what some of these freaking lines look like right here. Alright, so we just need the regular. We need a blank one. Alright, so let's get this up here a little bit. Make her a little bit bigger. Alright, so what do I need? You know, what I need is something that does something under this standard. A through infinity on, what do you got there? Dispersion measurement. Alright, so it'll disperse and come up in some damn vector position there, what a black hole is, IH. The problem is, in science, to the term of astrology, yes, this is only going to be something that is within the amplitude, the frequency, and things of that nature that refer to specifically black holes. And they're going to emit some radio pulses that are basically gravity waves. In lieu of the spectrum of gravity, you have to say that what that's going to be emitted is something that's IH. It's a value of the irrational, Planck's constant for that value. And you got to get there from A. So that's what this is going to be generally about here. I know I could use my math one for it, but that's for condension, a bunch of a lot of these other theses and stuff. But basically what you want to do is you can rewrite the world, you can rewrite the universe if you really wanted to. That's a problem because you're going to need to be a supermassive black hole first. But inside of here, away from astrology, in the department of A2, I want to give A a value. Right, and I got to do this in terminal velocity here, so that's what I'm going to do it as. I'm going to do it as the, not the micro nor the macro, but I want to do this in something towards the middle here that quantifies a new state that says I got a three-phase motor, M1 being the macro, M2 being the macro, neutrinos or a neutron star, for example. And there's an example of neutron stars to hydrogen to neutron stars, Kelvin on the black body radiation, all the way to black holes. Alright, so that's what that math generally looks like in here, and basically I want to integrate the mathematical formula for this. And so what I need to do is I need to first find an A base. Let's go capital and lowercase just to keep things in quantified for steps. In general, we know A equals B, A equals C, A equals D. A derivative is A derivative is X, so on and so forth. So it's very confusing to determine this. Here we have a concept of starting the standard of a, get this back down, get that out of here. We have this as a determining system of I have to start from a dispersion measurement. Well, there's a lot of things that disperse in a scattered pattern. After you've done certain indexes of a block in a tread line or something like that, the tailings on that function start to disperse out. There's a pretty consistent rate before it starts to disperse. And you could really even call that Hawking radiation if you wanted to. But it's a little bit convoluted around Sherpa's goat path on M1 and M2 to get there. So they're generally going to give you, I need you to output this. And that's the scientific experiment of determining the distance of the moon from Earth with the laser beam that they did. And then they'll failure proof your ass in the ground about Did you graph it? Did you go over there and check it? Can you believe these scientists? Because not even these scientists can believe that. I mean, they're going to do it because that's why they do what they do. All right. So inside of there, I just want to make that statement generally pretty clear before we get back to what is A. What is A? A is one thing by mathematical values. It's a dispersion measurement. It's B, C, D, A, B, BB down to the mathematical function. Well, let's do it mathematically. It would be A, B, C, A1 in a Jacobian matrix, A2, A3, B1, B2, B3. Now, that sounds pretty simple and straightforward, but when you click on one of these Jacobian matrices, let's say A1 or AA, you have a bit of a fundamental failure problem in the frontal lobe for the most part. You see me clenching out there a little bit. Basically what I mean by that is it starts to value very differently. Let's see if I can quantify this. I had a thought in hand. It was good. Any one square A is a Jacobian matrix. I can say A is a bunch of damn things, but in common sense of it, A is a stone mill, A is a manager of that stone mill, A is a worker of that stone mill. And that's where things get a little weird because A values under the difference between those terms. It's a abruptly long sequence with arbitrary long. Well, it'll be either Albin Heinrichs or Erode's conjecture is usually what I use for A, but AX. But in this case, it would be A1. A, B, C, D, E, F, G, H, I, J, K, L, M, N, P. Arbitrarily fit to that matrix, and if it doesn't fit inside of that matrix, I'm assuming that Jacobian matrix is going to catch it in the M2 phase of what that is. A, A, B, A, X, A1, for an example. It gives me the ability to then quantify some cicada-type code on this system that gives me 1 over F21 or F22. To be fair, that's about mathematically as tight as you can make it. I've seen it done a couple of different ways in different matrices, but obviously this is 1, 2, 3 in a part of something that is fairly tight. And so I would generally say, yeah, sure, I have no problem with the dispersion measurement. I think in the field for what it does, it solves the problem, but I think often people forget that this is useful for other things in the M2 matrix, way beyond this. And specifically, orders of priority, this would be the 2-phase at least. It actually can sit on the 3-phase too if you wanted to find a way to make energy off of that given this class. At the rate students drop, right? That dispersion measurement would give me a timeline. That timeline, if indicated over multiple series of 1, would give me something like a radio pulse burst. It would tell me the amplitude and frequency and vibration inside of that. Vibration vibration—generally a problem. I might need it M1, but in a orientation like this, vibration a bad thing. I want to see this vibration in the amplitude and frequency, not this or this or anything else that theta might throw at me, okay? And this could be obviously theta. And here we're just saying the angle across, but if I'm hitting it from this angle or I'm hitting it from this angle, you're all going to start to drop in a hurry, and I should be able to find a way to measure that. I should be able to even find a way to recreate that as much as take some of that vibration out of it. Here, instead of just the astrophysics nature of this function for a radio pulse, we're saying that somebody's going to emit some of this decay in a function. Now, energy is never created nor destroyed, and even Hawking's radiation defines that black holes will eventually evaporate. Yeah. So anyways, inside here, how do we get to determining these types of symbols? Well, I can say that any arbitrary system could equal this, and therefore change out the value of this standard. And I could say in a field, not astrophysics, because, it would be pretty specific here, but a lot of times they do this kind of crap that, is a statistical analysis that they'll pass one through the keyhole when they don't have integrity or something like that makes them real out there when they're still trying to early phase up, because they're not astrophysicists yet, but they need to make it somewhere, and you got all the equipment. Vector positions are what they are, though. We can get a lot of this stuff, but at the point, a lot of that scattered material is out there for making the certain stars in the universe visible. It makes, reality. It makes the limit under that percentage of what light's outside that door. Inside of here, I think it's critical that you understand that, and at least from my class as Master Masons, like I said, you can go ahead and, after you've understood this, and you know quantum physics, Carl Sagan, Penrose, and Fogg, Nuke, and Mars. Yeah, I'll give a dog a bone inside here and not really kick you too hard about what that is, because, well, you're not really trying to undersell the gravitational model of what it is. That's a teaching course, not necessarily look up into the stars and try to figure out astrology like Archimedes or Aristotle. Those would be integrals of something that you put together that says they have equal value under the standard for what they do. Here, a 3-phase to a 4-phase. Now, that's going to be chronologically set to time 1 minus time 2 because, well, you don't know, just like I don't know offhand the measurement of the years of life-to-death systems inside of that system that is going to start to disperse everybody in this room in a pretty big fucking hurry. Sorry if you don't like my lecture. There it is. You can find your way to the door. Nevertheless, you can sit here and you can try to learn something here today, just like every one of your students do, or I would have to do, just to keep up with astrologists and everything else inside of here about astrophysics and anything else. Astrophysics is just the quantification of physics happening in outer space that have common values under speed at that phase, which deserves its very own M2 matrix to what it defines. Well, we have to, as an overall whole, describe T1 to T2, which one's easier for us. That orientation is what's relative, not necessarily that, the bigger is the bigger and that's what I need to do, when realistically working on those quantifiable scales can happen at the micro with bacteria and viruses in a petri dish and the number of those cells in that sample. When, whatever model is best for them, because I'm going to go, they're closer to this one or they're closer to the macro with it, and I'm just going to start jumping on that index, which still gets me a stone mill manual about, well, that's how you map out your cosmic radiation background. From those points, it gives me temperature indexes and -1 and +1 stuff that really from any work site, dollar store, grocery store, salt crew in winter at Russia, race factory and excise palace over there, whatever the case may be, they're going to give me some kind of vector positions to say, all right, we say we graph the same thing, here's the standard test for those things, your test comes out with a different answer. You're right, that might be time orientated, but probably not if I'm going to run the same experiment parallel to you and say, well, Jupiter actually right there, or Larry, you know what I mean, because they have a lot of those effects inside of this, and Larry just might be Jupiter out there running some numbers, banging it out for the Kuiper belt, keeping us safe, buddy. And then every once in a while one passes through. I'll let that one slide. Inside here, it's something we got to consider about what this matrix is, because like I said, that matrix can give me a couple of different indexes of the type of school that I need to do, because then you wind up needing astrophysics numbers, but I don't do astrophysics work. On the other end of that, I might need the astrophysicist to kind of know those biology numbers and not get caught up in the the net force rabbit trap of FMA, momentum and potentials, momentum, potential, kinetics, other values inside of this form, because you should be able to adjust freely inside of a system like this. No, it doesn't always correlate to a black hole or something hydrogen related in the universe, but I don't need it to. A lot of things on my end of the world where I actually need to use a system like this and be able to actually snuff out some stuff to make it worth it at the back end is where I would start to say, hey, you got to be able to adjust this equation so it applies into a dispersion measurement anywheres. And that means specifically wherever you've heard the system dispersion. Something disperses, oil on water, that measurement can be quantified by this system. The T1 to T2, did you graph it? Stopwatch. In an area that is known to a specific set. that known area is a bucket, right, or a nice square tub. We'll use a square tub for oil and water, or soap on water, because okay, so any one of those oil, water, whatever disperses is going to have the fastest and the slowest rate that what they do in that. And that gives me an entirety of that matrix, which should be based in elements. It's going to be a little bit different with ions and free electrons floating around, or whatever the case may be. But it would still be scientifically correct if you understood that answer. Generally inside of here, like I said, it's usually a free will. How many people want to get away from a guy like me if I was doing mathematics? And I'd look in the room and I would take a graph under that index of it, and then maybe tomorrow we would do that same system, because it's a closed system. And as long as things can move and have entropy and Maxwell's demons in the room for in terms of, you know, the Planck length or anything else that they're teaching in Bell's equality for astrophysicists, Aristotle to Archimedes, there, so whatever you want to do there. I'm sure you guys know more names than I do if it's an astrology class here. But it's something you really have to consider about, well, that's fine, as long as my numbers are congruent to something like Bernoulli's and the end result still graphs the same way, then there's no reason that you couldn't make a parallel matrix. What you'll often find, though, is it still follows some basic rules that in subsets of sections there will be commonalities of why A is A for everybody. And usually why I use, I'm certainly not going to use D as dispersion, but it's a pretty common name. I bet you out of an average of 1,000 people, a bunch of them are going to, what does he got there? That name, what's the name of that game show there? Family Feud. Inside here, that there's out of 100 people that are asked this question, what does D reference mathematically to you? Oh, you will find a lot of stability. You will find a lot of dispersion. You're going to find a lot of everything. But in a blind study, they wouldn't know. They would just say, I'm emitting a radio pulse inside here, and what I have is people who kind of quantify supermassive black holes relative to minor black holes traveling around the Milky Way galaxy, like 100 of them. Anton was talking about it the other day, the wonderful person he is. And inside here, but again, we're just integrating those systems together by an n given value. Astrology is energy release inside here as effective ways that over history, you've done that before by integrating people's names and defining what those values can look like, being a dispersion measurement that quantifies the field theory, that quantifies the 0 and 1. Pretty straightforward and simple. And that alpha, maybe, almost an infinity. All right, whatever. And that's going to give me some basic 3x3 matrix. Anytime I see that, these two things, they got to equal something. This one minus this one plus this one, the neutron or the neutrino, durium, tritium, hydrogen, helium, any collisions under those matrices that form, like anything valued under the I, H, photon, W boson, he just emitting all kinds of radiation, that one there. And trying to enrich everything else around him, and energy is never created nor destroyed, so we need that beacon to hit some value that is not the quantification of all of this information, but at least a way to describe what that information is in a packet, and then you can attach other things to it to get it to that state. Okay, so catch you on the next one.